Today, we're going to use two skills that you already have: how to write formulas for various kinds of compounds and elements, and balancing chemical equations. And we'll put those two skills together to learn how to go from a sentence that's describing a chemical reaction into a symbolic representation in a balanced chemical equation. When we do this process, it's very, very important that you keep the phases and the steps of the process separated from each other, because the way that you do each step is different and for a different reason. So when you are given a sentence description of a chemical process, the first step is to write the formulas for all of the chemicals that are involved. And when we're doing that, when we're writing the formulas, we're determining the subscripts. So when we determine subscripts, we're thinking about the rules that we have for writing formulas of elements, compounds, covalent compounds, and ionic compounds. So first, for elements, if you have an element in your description, we've really got to think about, is it diatomic? Is it on our list of 7 or not? So I said there was going to come a time in the future where you needed to know all the diatomic molecules. Well, we have reached that point in this chapter. You do need to know those 7. So hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. If we're looking at a covalent compound, that naming schema uses prefixes to tell how many of each element. So in other words, they tell you the subscripts because they tell you how many of each atom are in a molecule. If we're dealing with ionic compounds, you use the charges of the cation and the anion to determine how many of each atom, or what the ratio is of the cation to the anion. So that's all stuff from previous chapters. The last chapter, we were using our understanding of how nonmetals combine to form covalent compounds, and how metals combine with nonmetals to make ionic compounds, to figure out what the formulas are. So you write the formulas, which is really determining the subscripts. You do that, you get that done, you're sure you're right. Then you move on to balancing the chemical equation and figuring out the coefficients. And when we're balancing, we're making sure we have the same number of each type of atom on each side of the equation. Balancing the equation. And that's where we're changing the coefficients. And that's where we ensure that there is the same number of each type of atom on the reactant and product side. So I always say it's very important to keep these two phases of the process separate. You can't use subscripts to try and get the same number of atoms. You can't use coefficients to try and balance charges or write a formula. They're two separate processes, and you've got to think about them separately. Down below here, I've got these clues and hints. You don't necessarily need to write these in your notebook, but if you want them all in one place, you can. I actually just copied this from the bottom of your homework worksheet. So I would suggest that you look through these. I'm going to show you on the next slide in a couple of examples how I put some of this stuff into play. So I already mentioned, like, watch out for diatomic elements, include state subscripts when you know. If you see the phrase burns in air, well, air is made of nitrogen and oxygen primarily. And if you know anything about building fires, you know that oxygen is the component of air that actually is involved in fires. So burns in air is like a big hint, oxygen. So we will go to the next slide and do a couple of examples so you can see these two separate processes. Okay, so when I get a sentence, when I get a chemical equation, the first thing I do is I try and translate into symbols, and then I figure out the formulas. So first it says magnesium metal. Well, magnesium is an element, and when it says metal, that's just a pure element. So magnesium is Mg. For elements, I have to think, is this diatomic or not? Well, magnesium is not, so the symbol is just going to be the symbol, Mg. And I'm going to put a solid because metal tells me it's solid. It reacts with, okay, so plus, the other reactant is aqueous hydrogen chloride. Hydrogen chloride. Every time I write a formula, I've got to decide, is this right? I don't see any prefixes, but hydrogen is +1 and chlorine is -1 if I go look at where they are on the periodic table. And I would go do that as like scratch work off to the side if I needed to confirm, oh, I just need one of each to get the charges to add up to 0. So for HCl, the subscripts are just 1s. Okay, and it's aqueous, so I can go ahead and write AQ. To produce, that to produce tells me, okay, I'm switching from talking about the reactants, reacts with, to the products. And there's going to be the hints that were on the previous slide, give you some other keywords that indicate, hey, we're switching from talking about reactants to products, like creates, forms, makes, anything like that implies, hey, we're about to talk about products. All right, so to produce hydrogen gas, well, hydrogen is another element, and I told it's a gas. Anytime I get an element, I've got to think diatomic or not. Well, Hofbrinkel, the very first thing in Hofbrinkel is hydrogen. So that is diatomic. Its formula will be H2. It comes in groups of 2 H's. And, okay, so I've got another substance in the products, aqueous magnesium chloride. So I've got a compound made out of magnesium and chlorine, and it's aqueous. Again, this is an ionic compound, so I've got to check charges to figure out subscripts. So that's good to do off to the side in scratch work. Magnesium is in the second column of the periodic table, so its charge is 2+. Chlorine, it's in the 7A column. It has a -1 charge, just like it did in hydrogen chloride. Well, if I look at that, to get a sum of the charges that's equal to 0, I have +2 and -1. So I need one more chlorine. And so my formula will be Mg1Cl12. So for ionic compounds, I used the charges to figure out what the subscripts are. So now I have officially gone through and thought about naming rules and what I know about elements to correctly write all the formulas with the right subscripts. Now I'm going to move to phase 2, which is balancing the chemical equation with coefficients. And I'm going to use a different color just to symbolize I am moving to the second phase. In this phase, I'm trying to make sure I have the right number, the same number of each atom. Well, one at a time. Here's the magnesium. There's the magnesium. That looks like it's balanced. I have 1 hydrogen. Over here I've got 2. So I need to put a coefficient of 2 to give me an equal number of hydrogen atoms on reactant and product side. Now I've got 2 chlorine as well, but that works out perfectly because I have 1 group of magnesium chloride, but there's 2 chlorine in each group. So actually, with that 2 there and 1's in front of everything else, that is a balanced chemical reaction. That is my answer, and I am done. Notice I put the state subscripts. They're sort of optional, but like if you're given it, for example, here it says aqueous or gas. If you're given the state, you should include it in the equation. We got one more example to look at. In this one, it says dicarbon hexahydride. That's my first compound. Well, I've got prefixes. That must be a covalent compound. I'm going to use the prefixes to write the formula. Di means 2, so C2. Hexa means 6, hydride is hydrogen, so C2H6. Burns in air. One of the tips said the part of air that burns or that we need for fires is oxygen. So burns in air is like code for saying oxygen. Oxygen is diatomic, so it's going to be O2, and oxygen is a gas. To produce, that means I'm going to make product here. Carbon dioxide, CO2, and that's a gas. And water vapor, that's one I know off the top of my head too, H2O, and it's a vapor, so that also will be a gas. So this time I had to use what I knew about covalent compounds to figure out the subscripts of my first reactant. I also used my knowledge that oxygen is diatomic to remember that it's not just O, but O2 in this case. So I finished the first phase, which is writing all the formulas based on the formula rules that we know. Now we're going to balance using the coefficients. I have 2 carbon atoms here, but this only has 1. So I'm going to put a coefficient of 2 there. Now I'll try the hydrogen. I have 6 hydrogen here, but they come in sets of 2 over here, so I'm going to make this a 3. Third, I saved oxygen for last. I've got 2 groups of 2 over here. On the product side, I have 4 plus 7. Oh, I'm running into that even-odd conundrum where I need to get 7 oxygen, but I can't because this is an even number. So I'm going to fix that by doubling all of my coefficients. So 2. This becomes 4. And the last one, become 6. And then I'll try the oxygen again. Everything else should still be right. I've got 4 carbon, 4 carbon, 12 hydrogen, 12 hydrogen. Now I have taken a look at oxygen again. 4 times 2 is 8, plus another 6, so that gives me 14. So my coefficient in front of my O2 is going to be 7, because 7 groups of 2 gives me 14. And now that problem is done as well. It's your turn to give this a try.